So the first part of this is on the other video. I did accidentally hit the wrong button. So we'll continue. Number 6. Write an equation in slope-intercept form through the points given. So the first thing I have to do is find my slope. How do I find my slope? It's my y's subtracted over my x's. So I'm going to go, this is my x, and that is my y. So I'm going to go -5 minus a -7, so plus 7, over 3 minus a -2, so it makes that a +2. -5 plus 7 is 2. 3 plus 5 is, or 3 plus 2 is 5. Then I have my slope and I have a point, and it doesn't matter which point you're going to use. You can, if you don't believe me, you can do it the other one out, but I'm just going to use the first point. So we have y minus 5, so I have it plus 5, is equal to my 2/5 times x minus 3. And this should be a negative, nope, this should be +2. So I go and I distribute. So I have y plus 5 is equal to 2/5 x. And how do I put this in my calculator? I go 2 divided by 5 times a -3. So you should get a -1.2. Then what do I gotta do? How do I get rid of my 5? I have to subtract 5. So I get y is equal to 2/5 x minus 6.2. Alright, suppose Felipe went paragliding and was 3,000 feet above the ground. He's going to descend at a steady rate of 180 feet per second. So our starting point is 3,000 feet. And he's going to descend, so minus 180, and it's going to be feet per second. And it says to write a linear function. Remember, linear is a line. So we have y equals, and since we have a slope and we have our starting point, our beginning, our b, we can use our slope-intercept. So we have y equals -180x plus 3,000. Let's label our graph down here. So our slope is always our rise, which is our y's, over our run, which is our x. So we're talking feet above the ground. So the number of feet, and over here is the number of seconds. So our independent variable is always our x. So that's our independent variable, because I can plug any number in and I can get y. So x is equal to the number of seconds. Our dependent, our y, depends upon what you put in, because it's waiting for you to put a number in. So our y is the number of feet above ground. Is this discrete or continuous? It's continuous because he's going to descend every single foot until he gets to the bottom. He's not going to skip a foot in the middle or skip a fraction. Also, you can have a fraction of a second and a fraction of a foot. So that's why it is continuous. So you can have a fraction of a foot or a second. Alright, graph it. Well, we know it's going to be 3,000, so I'm going to go by 500s. So we got 501, 502, 503. Then I have to go and figure out what number I'm going to use next. Well, I'm going to put in a 2 because I know it's going to take almost 16 seconds to hit the ground. And you can find that by taking the number you started with, and you're going to descend 180, so you can divide it out. That's 16. So it's 16 point something. So we can go take a 2 and plug it in. I have y equals negative 180 times 2 plus 3,000. So I'm going to take and plot, or to get that, I have negative 180 times 2 is negative 360 plus 3,000 is 2640. So this one was 2,500, so it's going to be somewhere in between here. And since I'm kind of guessing because there's so many numbers in there, I'm going to do the next number of 4. Since I go 2, 4, and I'm going to go 4. So I got y is equal to a negative 180 times 4 plus 3,000. I'm just putting the 4 into that equation. So I have negative 180 times 4 plus 3,000. 2280. So 2280 is approximately right here. So we'll connect those points, and there is a line because it's continuous. So we have 4, 8, 10, 12, 14, 16. I know it's going to be a little bit lower, more than that. Probably too much there. Probably should have been more of a steep.